All right, we're going to go ahead and take a look at our first free response in College Board Unit 4. So this is our probabilities, independent and conditional, and we'll see those in our using our formula chart. And then, of course, you got some binomial, geometric, and normal model probabilities. So our first problem here was a problem about the life expectancy of batteries. And they were comparing the new battery then to the traditional battery. And so, a couple things when you're reading and you see that something is stated to be approximately normal, then you might want to make a mental note of that. And of course, then they say that the lifespan of the new battery is 30, the average is 30 months with a standard deviation of 8 months. Okay. Then they go into this talk about the warranty, and we'll talk about that later. The warranty is they'll replace it if it's works for 24 months or less. All right. So the first question being, in how many months from the date of purchase is it expected that 25% of the batteries will no longer work? And so we're going to justify your answer. So let's see. A couple things that were needed for this problem. You had to indicate normal model and that you had a mean of 30 and a standard deviation of 8. So we'll take a look at what gives credit for indicating those things here in a minute. Also, you had to show your direction, or this was the lowest 25% of times. So that's how I needed to get that z-score at that location. Z-score at that spot is inverse norm of the area below is the z at that spot. So I had the negative. So then I set up my z-score formula here to see what that context value is. So what the months were at that spot. So this is the z-score formula set up, and then I come out with 24.64 months. So let's look at how people got credit for this problem. So first, to get full credit, you had to indicate the use of the normal distribution with a mean of 30 and a standard deviation of 8. There's a couple different ways that you could do that. And so we're going to talk about that over here on this next. Component 1, that normal model um, clarification could be done with a graphical display with the horizontal axis labeled with the mean and the standard deviations of the battery lifespan. So I did not do that completely. I had the mean on there, but I did not put 38 and go up standard deviations. So I would not have gotten credit for that. Calculator syntax. They're starting to have some of that creep in, and we've not practiced that or done that. We've always just not lend ourselves to that kind of shortcut. So we are going to skip that. But you might have done this z-score. So if you show the correct standard z-score calculation, and they give, for example, z equals x minus mean over the standard deviation, the 8, or even if you had filled in the numbers here, negative 0.6745, and then x minus the mean over the standard deviation, you may have even done this, the mean plus negative 0.67 standard deviations. So those all would have given credit for indicating normal model um, being used. Okay, second piece that needed to be done is setting up that 25th percentile. So we needed to see somehow that you had this negative 0.67 as the z-score indicated. So z-scores equating, if you had that negative 0.6745, that qualified that as the correct percentile. So you see this z-score formula set up gave you a whole lot of credit. It gave you the normal model statement, and it gave you the lower 25th percentile statement. All right, and then of course the third thing you had to have was the correct answer, which was 24.6 months. And so if you have all three of those correct, then you get E for part A. And if not, if you only get two of those correct, you get partial. All right, let's go to the part B. Suppose one customer who purchases the warranty is selected at random. So this is a person who did bought the warranty. So let's review that real quick. For a price of $50, that guarantees that if the battery would be replaced at no cost to the customer if it does not work longer than 24 months. So if it quits working within 24 months from the date of purchase. So the question wants to know, what is the probability that a randomly selected customer will require a replacement? So will be taking advantage of that feature. So that is this idea of us having the 24 month mark. I worry that I did not satisfy one of the components to one of the required pieces to this problem. And I could have, if I had shown a normal model and labeled this 24 and then shaded the area that I wanted. So if I had done something like that, then I would have had no question about receiving full credit on part B. Because in order to get full credit on part B, of course, I put 24 in for the X value and I got the Z score. So then I got this lower area by accumulating that, which this syntax does not give me directional um, credit. So that's the percent chance. I could have, if I had worded my answer better, there's a 22.66% chance the customer who purchases a warranty will have his or her battery replaced at no cost. And then something like, since it broke uh, within 24 months. Okay, that kind of thing. So there, that little bit of statement would have solidified that I do get full credit, because let's look at what you needed for full credit. So here, to get full credit, you had a graphical display, and this could be covered in part one, um, with that boundary and the direction. See, I didn't do that. I didn't put that 24 or less. You could have used calculator syntax, which we're not doing. Okay, you could have used words. So if I had said probability within 24 months, I would have gotten credit for that boundary and direction. And another way is I could have written the probability notation. The probability of getting a month less than or equal to 24, or the z-score less than or equal to negative 0.75. So they don't say in the notes that you get credit. Let's see. No, it doesn't give any other notes, that just having that z-score of negative 0.75 indicates that lower direction. It's not indicating a shaded area. So I think I would have missed getting full credit on that, because I did not, I was so close, but just didn't somehow get that shaded area, the direction, that kind of thing solidified. All right. So of course you get an E if you have all of those components, and a let's see, let's go back. Yeah, to get a full credit, you had the boundary of 24 and the direction that I missed. And then I did do the correct probability. Okay, so let's see here. See, component one can be satisfied with this, but not component two. All right, so I'm pretty sure I would have gotten a P on that, unfortunately. Next is the last part, and that was about a weighted average to see the expected value of the gain. So if you think about it, this 22.66% of the time, that is the time amount, the proportion of times, or the proportion of phones that will cost the company $150 because they had to be replaced that percent of the time. And the law of large numbers says that that's the probability, and that's what's going to happen. That's the proportion that will end up losing the company $150. But the company will gain $50 whenever they take into account, all these other times the 77 point whatever, so 1 minus that 77.34% of the time, then they get to keep people's $50 that they spent. So then what's happening is you are losing $150 that percent of the time, and you are gaining $50 that percent of the time. So that works out that on average, for every warranty purchased, the company is making $4.68. So over tons and tons and tons of warranties, they're making tons and tons and tons of money on those warranties. All right. So credit on that comes from providing the expected value with the two appropriate probabilities that add to 1. So if you had missed the probability in part B, but you carried that wrong number, say you got 30%, but you carried that number and worked it out correctly in part C, you get full credit for part C. You just missed that probability in part B. So if you use the 30% as the failure rate, losing 150 30% of the time, that would mean 70% of the time you're gaining $50. Then it comes out with the correct number. You get that full credit. All right. So if it only satisfies one of those, because that's what this says here. The notes is that probability is consistent with the value computed in part B and added to part 1. Therefore, you can still, if the correct probability is used, then you get full credit. Or if that probability from part B is used, you get full credit. All right. So see how you would have done EEE. You get a 3 for EEP. Here's all the ways you can get a 2, EEI, EPI, EPP, and then a 1, EII or PPI. All right. So I hope you did well on your uh, 2019 problem number 5.